Okay, today we are going to discuss about the Snellen's chart limitation. It's a very important question. And I think I always used to ask students about the Snellen's chart's limitation and or exactly at the same time what is the basic benefit of the ATTRS chart or whatever. Let's move on and we will discuss later on about ATTRS chart and I think visual acuity it will take 15 parts. I'm going very slow. Okay, let's just start. So Snellen's visual acuity chart is very standard in worldwide, isn't it? Visual acuity is taken as a very standard gold standard in case of visual outcome, primary outcome, isn't it? Someone has let's say for example, if we are defining low vision, yes, definitely there is visual field portion, but uh, visual acuity is also very important part, isn't it? So less than 618 till 360 and all these things. So visual acuity is taken as a very standard primary outcome in case of clinical trial and worldwide. Okay, obviously Snellen's visual acuity is very popular in case of visual acuity chart. Snellen has historically been most popular visual acuity chart and clinical practice. Even still, um, Snell's visual acuity chart is used most frequently in clinic. Okay, so why it is there is a limitations in Snell's visual acuity chart? Because one is there is no standard or globally uniform Snellen chart. Okay, no standard and globally uniform Snellen chart. There is no. Okay, chart differ from manufacturer by manufacturer, especially see uh, font. Font can be serif and non-serif, and letters and the number used it can be different, and the vertical line of spacing and the ratio of size progression. These all things are not worldwidely globally uniform. They can differ from manufacturer and manufacturer. Vertical line and spacing and size progression, which is very crucial in case of HDRS chart. Okay, I will later on. Let's move on forward. So scoring method is used in Snellen chart is line counting when the majority of letters of the row are read and credited is given to entire line of majority of characters on the entire. See, so to read first line, it's only you have to use only one letter, and if you have to read a second last line, it means you have to read seven letters, and if you read five letters, sometimes you use something like that 6 9 parse, or sometimes you use 6 9 minus 2 or whatever, but that's not the case. It's not standards. You cannot count on each letter. Okay, and another thing, sometimes you just give it 6 9. Okay, so that's the problem there, because if credit is given for entire letter and you read more partially, isn't it? And that's the problem here. Even you wrote 6 9 parts, it's not that standard. You cannot put it into the calculations, and if you even if you wrote something like that, two letters are missing, it's not standard. You cannot calculate it. You cannot put it in the software and you can calculate it. Okay, it's quite difficult there. So obviously, see, certain letters are easier than recognized in certain letters. For example, P and F, I always say in my clinical practice, if you move to this point, then some patient, like let's say example, his vision is 6 9 parse and these letters are in 6 9 row. Then sometimes F is a P and P is a F. It's quite difficult, isn't it? Sometimes T patient called Y. Some there is Y patient called T, isn't it? You will see a lot of time in your clinical practice this kind of, and I think it's way difficult. Sometimes C patient called O and O patient called C. It's way difficult, and most easy I think to recognize is E. E is quite easier to recognize. So it's that's not similar. That every letters I have and didn't have equal recognition, equal easiness for recognition. So it's quite important to understand. Okay, the number of letters per line are variable. That's crucial. That's really crucial. See, for the first line, which is 616, is one letter, and for the last line, which is 6 6, I think 7 letters. Isn't it? That's way, way, way different thing. And first letter, it's always easier to recognize, and all it's only one letter. So the line with the letter spacing are closely adjacent. And what happens when the letter number increases? This means the crowding also increases. So that's why whenever you move towards the more and more finer vision, more and more crowding increases. Isn't it? Isn't it simple? So the line with the letters is spaced too closely and adjacent counters results in crowding effect and overlay which affects in visual acuity. So it's really conundrum that see when there is good vision, this chances of having 660 is very good, isn't it? The chances of having 612 is difficult. And when if there is difficulty in eastern and south, exactly at the same time crowding is increasing. It's not that. In case of HDRS, there is always a five lines, always a five letter, five letter, five letter, five letter. But in case of Snellens, one, two, three, four increases and increases. Every increasing letter has increasing crowding phenomenon. So that's quite difficult thing. Okay, fine. So that's a very important thing. As you move from up to down, number of letters increases, and as number of letters increases, crowding phenomenon increases, and more difficult to recognize things, isn't? That's the very good point you have to understand. But in case of ETDRS, there is equal crowding in every row. Another fallacy: there is no specific type or font used in Eastern Start. I have already told. Some fonts are serif, some for sans serif, and sometimes you use serif, and sometimes you use sans serif, and different fonts can be used, but they are not calculated for recognition, calculated for easy for recognition for the patients and for local patients and all these things. And it's quite difficult that sometimes you use this type of jet, sometimes you use this type of jet or this type of jet, and that's the different thing. Okay, so another thing that I have already told you, but I want to release in this slide, the progression of the letter size between these steps are not consistent. See, in case of ETDRS, always it's 25% size is reduced from one row to another row, from another row and another row. It's always there. But in case of Snellens, it's not that always size reduced in progression, certain progression. It's not that we cannot predict that. So that's why it's quite difficult to changing viewing distance and thus changing the scale according to the under or overestimate the error. So we cannot uh, exactly predict things from how this line is bigger than the adjacent row and smaller than adjacent row or bigger than adjacent row. It's quite a problem with this slide. So you must understand this concept. Okay, so progression of letter size between these steps is not consistent. This is also fallacy of Snell's letter. Okay, so you must understand what the fallacies are. So inconsistent font size progression, inconsistent and inconsistent letter size progression, and crowding phenomenon definitely, which is very important. And obviously whenever you read 4 or 5, you said all read, or it's 69 powers 69 minus 2, they are not that much standard, and it's very difficult with the calculations whenever we put into the SPSS or MATLAB or whatever for the analysis. It's quite difficult when there are all shortcomings are uh, addressed by ETDRS study chart. Then later on we will discuss on it. Okay, so that's it, and this is my reference by Professor Dr. George Smelis. So bis dann, tschüss.